बिस्मिल्लाहिर्रहमानिर्रहीम। सेकेंड स्टूडेंट, आज हम डिस्कस करेंगे यूनिट 20 न्यूक्लियर फिजिक्स के लेक्चर नंबर 3। इसमें हम डिस्कस करेंगे इस चैप्टर के कंसेप्चुअल क्वेश्चन। तो चलो बच्चे स्टार्ट करते हैं कंसेप्चुअल क्वेश्चन को। कंसेप्चुअल क्वेश्चन नंबर 1 है कि वाई डू heavier nuclei have more neutron than proton। मतलब हेवियर न्यूक्लियाई में न्यूट्रॉन की तादाद प्रोटॉन से ज़्यादा क्यों है और वो क्यों हेवियर है। देखो बच्चे, वजह यही है कि हेवियर न्यूक्लियाई हैव मोर न्यूट्रॉन देन प्रोटॉन फॉर इंक्रीजिंग द स्टेबिलिटी ऑफ द न्यूक्लियस। मतलब न्यूक्लियस की स्टेबिलिटी को ज़्यादा करने के लिए इसमें हैवी न्यूक्लियाई में न्यूट्रॉन की तादाद ज़्यादा होती है। इसको बच्चे एक्सप्लेन करते हैं। देखिए, ये हमारे पास एक न्यूक्लियस है, इसके अंदर है न्यूट्रॉन, प्रोटॉन और इलेक्ट्रॉन ऑर्बिट में रिवॉल्व कर रहे हैं। सो इन न्यूक्लियस प्रोटॉन इन न्यूट्रॉन आर प्रेजेंट। प्रोटॉन आर पॉजिटिवली चार्ज पार्टिकल। There exist nuclear forces of attraction as well as Coulomb force of repulsion between proton. So the Coulomb force of repulsion decreases the stability of the nucleus. On the other hand, the neutrons are neutral particle. There is no Coulomb force of repulsion between neutron, so there is only strong nuclear attractive forces among neutron. The strong nuclear forces and Coulomb force of repulsion between neutron enable them to hold the nucleons together and thus increases the stability of the nucleus. Short question number 2 है बच्चे कि रेडियम has a half life of about 1600 years. If the universe was formed 5 billion or more years ago, so why is there any radiation left? देखिए बच्चे, को हम एक्सप्लेन करते हैं। At the time when the earth was formed, all the elements, stable and unstable, were formed in varying amount. Since most of the unstable nuclei had a half-life much shorter than the age of Earth, even though they have longer time to decay. Now we are given that half-life of radium is कि उसे हमें दिया है कि हेडिंग हाफ लाइफ है कितनी, वो है 1600 ईयर, मतलब 1.6 10 की पावर 3 ईयर। तो एज ऑफ अर्थ कितना दिया है, 5 बिलियन ईयर। सो नो इन इनफाइनाइट टाइम इज रिक्वायर्ड फॉर ऑल एटम ऑफ रेडियो एक्टिव एलिमेंट टू डिके completely. But earth life is not infinite, it is still how much, 5 billion year. So we can still find that existence of radium element in a nature. Number 3 है बच्चे कि if we focus our attention on a specific nucleus and a radioactive sample, can we know exactly how long the nucleus will live before a decay? देखो बच्चे, हम जानते हैं इसका आंसर नो है। It is not possible to know exactly how long the specific nucleus will live before it decay. Radioactive decay is a random and mere half-life are based on the most possible rate. So we know that a nucleus will decay at some point. So we just cannot predict when it could be anywhere between instantaneous and the total age of the universe. Although scientists have defined half-lives for different elements, so the exact rate is completely what was random. Short question number 4. Why are neutrons such good projectile for producing nuclear reaction? देखिए बच्चे, the neutron are good projectile for producing nuclear reaction. Reason plus explanation में हम लिखते हैं कि the necessary condition for starting a nuclear reaction are that the projectile must have so much energy, so with the help of which it can reach the surface of the nucleus or enter the nucleus. The projectile are of two types. एक होता है न्यूट्रल पार्टिकल और दूसरा होता है चार्ज पार्टिकल. So the neutral particle is more efficient to cause nuclear reaction. It is because they don't experience Coulomb force of repulsion due to nucleus or a electron. Thus, it can reach the nucleus very easily by consuming less amount of energy and can cause nuclear reaction easily. On the other hand, a charged particle is less efficient to cause nuclear reaction. They need greater amount of energy for approaching the nucleus because they experience Coulomb force of repulsion. Due to positively charged nucleus, thus a huge amount of energy will be needed for a charged particle for causing nuclear reaction. Question number 5 है बच्चे कि why neutron activated nuclides tend to decay by beta rather than beta plus. अब जेके बच्चे the neutron activated nuclei tend to decay by beta minus 1 than beta plus. The emission of electron from the nucleus can take place when neutron emitting electron in convert to proton. रिएक्शन है बच्चे देखिए N0 ये हमें देगा प्रोटॉन प्लस बीटा माइनस 1 पार्टिकल. सो यहाँ पे N01 P1 plus 1 electron. This means that the beta particle is formed at the time of emission. That is why at the time of emission of beta minus 1 particle, the charge number Z of the nucleus increases by 1 unit. So, but no change in its mass number A because the mass of electron is very small. It should be noted that during neutron activation, neutrons are added to the nuclei, which increases the neutron to proton ratio. So, the nuclei tend to decay by electron emission. For example, thorium 9232 ये हमें देगा अगर हम न्यूट्रॉन ऐड करें पैलेडियम प्लस बीटा माइनस 1. क्वेश्चन नंबर 6 है कि वाई आर स्मॉल एंड लार्ज न्यूक्लियाई अनस्टेबल. इंपॉर्टेंट क्वेश्चन बच्चे. देखिए हम जानते हैं बच्चे कि द बाइंडिंग फ्रैक्शन और पैकिंग फ्रैक्शन, द measure of stability of a nucleus, the greater the binding energy per nucleon, the more stable of the nucleus. मैथमेटिकली बच्चे हम लिखते हैं कि पैकिंग फ्रैक्शन के लिए फार्मूला है EB डिवाइड बाई A. अब बाइंडिंग एनर्जी हमारे पास बच्चे बराबर होती हैं ZMP प्लस NMN माइनस M C स्क्वायर A. अब सबसे पहले स्मॉल न्यूक्लियाई को डिस्कस करते हैं. देखिए the decrease in packing fraction F for small nuclei A due to surface effect. The particles are near the surface are less strongly bound than the nucleon at the interior. So the smaller the nucleus, the longer is the percentage of constituent is the nuclear surface. For example, helium-24 and oxygen 816 and is therefore unstable. Large nuclei के लिए the decrease in F for large nuclei is because of large number of proton. So the Coulomb repulsion between proton oppose the binding effect of nuclear force. So therefore nuclei with a large A are unstable. फॉर एग्ज़ाम्पल ये हमारे पास है रेडॉन 8E6 222 और यूरेनियम 92238। इसके बाद है बच्चे शॉर्ट क्वेश्चन नंबर 7। शॉर्ट क्वेश्चन नंबर 7 है इम्पॉर्टेंट कि वाई इज कन्वेंशनल फिशन न्यूक्लियर रिएक्टर एबल टू एक्सप्लोड एज अ बम। देखिए बच्चे, conventional fission nuclear reactor does not explode as a bomb because of the controlled fission chain reaction. देखिए बच्चे, the term nuclear reactor is used to refer a device in which controlled nuclear fission chain reaction can be maintained. In such a device, neutrons are used to induce nuclear fission in controlled manner. This control can be achieved by using special type of material like boron in the core of reactor in the form of control rod, and also multiple barrier approach scheme is adopted in a reaction. So this helps to prevent the radioactive material in the atmosphere in severe condition, and with accident happen, these control rod drop automatically in the core of and stop the fission reaction. So nuclear reactor are in a nuclear reactor are recently safe devices. While in nuclear bomb, the fission is in the uncontrolled way used for destructive purpose. In bomb, enormous power is released every a very short duration, but in reaction there is a control on power, so it can produce power for peaceful purpose. Question number 8 है बच्चे important कि why does the fusion of light nuclei into heavier nuclei release energy? The fusion का मतलब बच्चे होता है combining. The fusion of light nuclei forms a single heavy nucleus. In this process, energy is also released. देखो बच्चे, in fusion reaction, two light nuclei combine form a single heavier nucleus. The mass of the resulting nucleus is less than the sum of the mass of the particle constituent nuclei. This decrease in mass is called mass defect. This defect in mass is represented by del m and is given by the formula del m is equal to zmp plus nmn minus m. The mass defect is converted into energy associated the relation E is equal to mc square. In other words, we can say that energy is released during the fusion of two lighter nuclei into a single heavier nuclei. 9 number of question very important कि what factor make a fusion reaction difficult to achieve? The following factor make the fusion reaction difficult to achieve. First one है बच्चे, fusion is the process by combining two nuclei to form a heavy nucleus. But for the fusion of two nuclei, we need very high temperature, about 10 to the power 8 Kelvin, which cannot be obtained easily. Second point है बच्चे, for fusion we need proton cycle or carbon cycle which are completed in several steps and need very long period of time. Third point है कि the atom become ionized at temperature of 10 to the power 8 Kelvin and exists in plasma state. This stage cannot be achievable. तो ये बच्चे कुछ पॉइंट थे जिसकी वजह से फ्यूजन जो है वो अचीवेबल नहीं है. सो थैंक यू स्टूडेंट्स.